All right, guys, what is up? This is the Unit 5.1 notes. It is in this packet right here. It starts on page 1. So our learning target today is I can determine when figures are similar and find the common ratio. So we are talking about similar polygons. Okay, next unit we're going to talk about congruent polygons, but today we're only talking about similar polygons. So two polygons are similar when they're not the exact same. They're not the exact same, but they are the same shape. So for instance, two triangles could be similar because they are the same shape. Two squares could be similar because they're the same shape. But the deal is they have to be different sizes. Okay, so if two polygons are the same shape, so a square, a triangle, a rectangle, a hexagon, but different sizes, meaning one's bigger than the other, then they are what are called similar. Two criteria have to be true. Number one, the corresponding angles have to actually be congruent. They have to be the same. Corresponding angles have to be congruent, which means the exact same measure. Okay. Now corresponding sides, on the other hand, criteria number 2, they are going to be what we call proportional. We're going to talk about what that means. They are not the same measure. They're proportional. Okay. Angles, congruent, sides, proportional. So let's take a look at example 1. In example 1, it says that triangle ABC is similar. So that symbol right there means similar. So let's remind ourselves this is a new one. This means similar. Let's review a couple of the other symbols. This one, this is an equal sign with a squiggly on top. That would mean congruent. You've probably seen that before. And then obviously this with just the equal sign is equals. So make sure you know the difference between those three options. So this is similar, this is congruent, this is equal. Okay? All right. So triangle ABC is similar to triangle PQR. That means their angles are congruent, their sides proportional. So let's talk about which ones are which. If you look here, each of these triangles are represented by arc marks. So this angle and this angle both have one arc mark. So that would mean that angle A and angle P would be congruent. They both have one arc mark. Let's do B. B and Q are also in the same place on the similarity statement. So B and Q, they also have two arc marks. So they are congruent. Angle C and angle R, they both have 3 arc marks. They're also the third letter in the similarity statement. A couple different ways you can identify. Okay, let's talk about AB. This is a line. AB is not going to be congruent to any other line necessarily. But AB would be proportional. This is the symbol for proportional. It's like a colon. AB would be proportional to something. Well, A has 1 arc mark to B, which has 2. So you need to look at the other triangle and think, okay, what has 1 arc mark, P, and then what has 2, Q. So if this is AB, it went from 1 to 2. This would be PQ. It went from 1 to 2. PQ. You would do the same thing on these. So if I were you, I would pause the video and try to do these on your own before I show you. BC would be from 2 to 3. 2 to 3 would be QR. CA would be from 3 to 1. R to P. See how it's just a pattern. Okay. What about example 2? Example 2, let me use a different color just to spice things up a little bit. If the quadrilaterals below are similar, there's that word again, that means that they are the same shape but different sizes. What must be true? Well, you know that all the angles have to be congruent. So that means angle A would be congruent to angle E. Angle B would be congruent to angle F. Notice how they both have 2 arc marks. And then what are some other ones? What about angle C would be congruent to angle G? Then angle D would be congruent to angle H. So notice how all the angles with the same number of arc marks are congruent. They're the same measure. So if A was 50, E would be 50. If B was 50, F would be 50. They're the same measure. What about the sides? The sides are proportional. So let's pick a side over here. Let's try AB. What would be proportional to AB? Well, AB is right here. EF is in the same place. It looks like it has the same arc marks. So it would be EF. What about BC? BC would be proportional to FG on the bottom. So hopefully you're like, Mr. Colston, this really isn't too bad. You are just finding the pattern. CD, GH, DA, HE. Not too bad. Okay, so that's it for page 1. Now let's look at another example. Example 3. Let's take a look at example 3. This is on page 2. Example 3. So here we have another similar polygons. We're trying to find the common ratio now. So let's talk about what the common ratio would look like. If we are trying to find the common ratio from EFGH to ABCD, here's the thing with common ratio. It matters the order that it was written in. So notice here EFGH is mentioned first. So we need to make sure that EFGH is first. ABCD is mentioned twice. We need to make sure this is the second one. So let's talk about what that looks like. Let's just pick, by the way, common ratio, you don't deal with angles, you're only dealing with sides. So pick a number over here. We're just going to pick a number. Any of these sides. Hold up. We need to start with EFGH. Sorry. We're starting with EFGH, so we need to pick any of these numbers on the sides. Pick any of them. Let's pick 5. So we're going to write 5, and we're going to try to figure out the common ratio. So we're going to put 5 over something. 5 is EFGH, and we need to put what matches it in ABCD. So 5 matches 10. Okay. If it helps, let me use colors right now. Sorry, I did not use colors earlier. 5 and 10 match. Okay, 5 and 10 would match. Now, if you put 5 over 10 in the calculator, that would reduce to 1 over 2. Okay, that's one of them. Let's try a different one. In addition to 5 and 10, 4 and 8 would also match. Now notice, we have to put it in a particular order. We have to put what EFGH is first. So 4 comes first over 8. 4 over 8 would equal 1 over 2 as well. That would also reduce to that. What about a different one? How about 3 and 6? Okay, 3 and 6 would also reduce to 1 over 2. So we have 3 of them that are reducing to the same thing. Let's try one more. What about 5 and 2.5? Remember, EFGH needs to come first, so it's going to be 2.5 right here over 5, which again would reduce to 1 over 2. So it appears that we have a common ratio. All of our ratios reduce to the same amount. So our common ratio is, you can write it in one of two ways. We can say 1 over 2, just like that, or 1 is proportional to 2, like that, like we did earlier. Okay. So that is what we call the common ratio. Now, let me pause for a second and think. Order matters. So if I were to have said, what is the common ratio from quad ABCD to quad EFGH, 1 to 2 would not have been correct. Would have needed to be 2 to 1. They needed to flip. So notice how order matters. If these would have been flipped, it would have been 2 to 1. Okay? Example 4. Determine if the figures are similar and justify your answer. So basically, we are determining if they are similar. So it's going to be like yes or no. Yes, they're similar, or no, they're not similar. So our answer is going to be either yes or no. What are the two criteria for things to be similar? Figures to be similar? Criteria number 1, all angles must be congruent. That's the symbol for congruent. They all must be the same, corresponding angles. All sides proportional. Okay, another way of saying that is need a common ratio, like we did in example 3. Okay, are all the angles proportional? Are all the angles congruent? Let's check. We can check it really quickly. 37 and 37, are those the same? Yes. 53 and 53, are those the same? Yes. This means 90 degrees and 90 degrees. Are those the same? Yes. So all of my angles are congruent. Yes, yes, yes. So that's good. But we're not done yet. We don't know that they're similar, okay? Because let's say all the angles were congruent, but not all of our sides were proportional. So we wouldn't know if they're similar yet. Let's talk about all sides are proportional. So here we're going to kind of do the common ratio thing again. So let's just do left to right. It doesn't give us an order here, so let's just do left over right. Let's pick a number over here, a side number that is on the left triangle. Whoops, sorry about that, guys. On the left triangle, pick any of these numbers. Let's pick 9. 9, and then whatever matches it on the right. 9 matches 6. 9 over 6 would reduce to 3 halves. What about 3? 3 over 2, okay, it already reduces to 3 over 2, so those match so far. Let's try our last one, 18 over 12. That would also reduce to 3 over 2. Divide by 6 would give me 3, 2. So it appears that we have a common ratio. All of our sides are proportional, so that is good to go. So yes, they are similar. So on your homework, you're going to basically prove both of those things are true or not true, and you'll say yes or no, they're similar. Okay? All right, last page, page 3 of your notes. Guys, these are pretty similar. Ha, they're pretty similar. I'm making myself laugh. Those of you that are watching this video, I hope y'all laughed at that. I'm saying example 5 and example 6 are pretty similar. All right. Example 5. Answer the following questions about the figures below. A couple questions. Here, all it's asking us to do is to match the letters so it's in the correct order. So let me show you what I mean. We need to put these 4 letters in the correct order. So let's do it one by one. What matches A? E. What matches B? F. What matches C? G. What matches D? H. Now, it just so happened to be that both of the quads ended up in alphabetical order, but it's not always going to be like that. It just happened to be like that. Now let's find the common ratio. Again, let's just pick an order. So let's do left over right. We don't have to do them all, but let's do a couple. So x over 6, would that be useful? No, because this is a letter. That wouldn't be helpful. Z over 1? No. 8 over y? No. So all those 3 that I just picked to try to start making a ratio don't work because I have letters. What about 12 over 3? 12 over 3. So if we're going from A, B, C, D, that's 12, to E, F, G, H, that's 3. What is 12 over 3 reduced to? It would be 4 over 1. So your common ratio is 4 to 1. All right. So in other words, this is 4 times as big as this. Okay, so now we're going to get into solving for those variables, x, y, and z. Here's how we're going to do it. For all 3 of these, we're going to make proportions. All 3. So when we're making a proportion, we got to pick a strategy and stick to it. So I'm going to do big over small. I think it's always good to just do the left over the right. Just keep it consistent. Big over small. So we always need to make a proportion like this. If we're trying to solve for x, okay, On the left, we're going to want x to be here at some point. So look at your picture. Where is x? It's not over here on the right. It's in this big one. So right here is x. So I'm going to write it next to big x. What matches x in the small figure? 6. Write it on the bottom. And then on the right side, you really need 2 numbers. You shouldn't have any letters anymore. So what is a number on the big? Well, 8, but that would land us with y, so that wouldn't work. So let's do 12 and 3. 12 over 3. Now we can actually solve this proportion and figure out what x is. Now we just cross multiply. 6 times 12 would get us 72. X times 3 would get us 3x. Divide by 3 on both sides would give us 24. 24. Okay. We keep doing the same thing. We're going to do big over small. So if we're trying to find y, is y in the big? Y is not in the big, so y is going to be on the small. What matches y in the big? 8. And then, guys, let's just keep using the same ratio, 12 over 3. Cross multiply, 24 equals 12y divided by 12. 24 divided by 12 is 2. So y is 2. We already know x was 24. Notice how we're starting to fill in the gaps. We only have one more that we don't know. So z, let's do big over small. Big, z is in the big, so z is on top. Small, what matches z over here? 1 equals 12 over 3. 12 over 3. Cross multiply. 12 equals 3z. Divide by 3 on both sides. 4. Okay, so z would equal 4. All right, so basically, guys, you're making proportions and cross multiplying is basically the name of the game today. Example 6. Let's take a look at example 6. Answer the following questions about the figures below. Quad TSRU is going to be similar to quad. I don't really like this question a whole lot, but basically you got to show what order it needs to be in. So the same spot T is in, T to S would be like P to N, quad P to N. S to R would be like N to M, and then you'd finish it with Q. I don't really love that question. Let's talk about common ratio. So the common ratio here, you need 2 numbers. If we're going from TSRU to PNMQ, that's our ratio, so we need to make sure we're consistent. What's the number over here? What about 25? 25 and X? Not helpful. What about Y? No. 30 over 18. So 30 over 18 would be our common ratio, but that's not simplified yet, right? So we could put it in the calculator, or we could just kind of start playing around with it. If we divided by 2, we'd get 15 over 9. If we divided by 3, we'd get 5 over 3. I bet that's about as simple as it's going to get. 5 to 3 is our common ratio there. Okay, these at the bottom, let's do these real quick. If we're trying to find x, let's stay consistent. So let's do left over right. Let's just make that our strategy and stick to it. So we're going to have a proportion here. Same thing over here. We're going to have a proportion. So let's do these one at a time. So x, we're going to have left. So x matches what? 25 equals 18 over 30. You could cross multiply. We could get 18 times 25. Let me do that real quick. 18 times 25 would be 450 equals 30x. If you divided both sides by 30, you'd get 15. So x would be 15 right here. What about y? So y, what's on the left? 15's on the left. Y is on the right. So y is going to go on the bottom over 15. And guys, let's just use the same ratio, 18 over 30. Multiply here. 15 times 30 would give us 450 equals 18y. Divide by 18 would give me 25. So y is 25. Okay. So guys, hopefully y'all feel good about that section. You can watch the next video if you want to watch 5.2. Have an awesome day.